Since we just learned about a plane, a hyperplane, square, circle, uh, hyperspheres, ellipses, ellipsoids, hyperellipsoids, let's learn another concept of squares and rectangles. Of course, this is also a very important shape, right? In 2D, we've studied a lot of them in simple coordinate geometry. Let me give you an interpretation of it and connect it with some programmatic ideas like if-else. This is a very beautiful idea in itself. So let's assume I have a two-dimensional. Of course, we'll show everything in 2D and extend it to high-dimensional spaces, right? So let's look at a rectangle. So let's assume I have two axes, x1 and x2. So let's assume I draw a rectangle here. The first thing you should notice is that this rectangle is parallel. So the sides of this rectangle are parallel to your x1 and x2 axis. Such a rectangle is called axis parallel rectangle. It's called an axis parallel rectangle. Because I could have drawn a rectangle slightly differently like this. I could have drawn a rectangle like this, right? This is also a rectangle as long as these four sides are perpendicular to each other, right? But this is not axis parallel because this side is not parallel to your x1 axis or your x2 axis, right? This is at some angle to your x1. So this is a non-axis parallel rectangle. We will focus mostly on axis parallel rectangles because it has a very nice geometric intuition that connects very, very well with the ideas of if-else conditions and nested if-else conditions in programming. Let's see. So let's assume this value is 5 and let's assume this value is 2, right? This value corresponding to this value corresponding to this. Let's assume this value is 3. Let's assume this value is 4, right? If I want to determine whether a given point P, so let's assume I have a point P with P1 and P2. Suppose if I want to determine if a point P lies inside this circle or outside this inside this rectangle, axis parallel rectangle, or outside this axis parallel rectangle, how do I do it? I can write it with simple if-else loop, if-else conditions. If P1 corresponds to x1, right? If P1 is less than 5, if it's strictly less than 5, and if P1 is greater than 2, right? Similarly, if P2 is greater than 3, and if P2 is less than 4, then P lies inside the circle, inside the square, inside this rectangle, right? So why did we write this? So what does P less than 5 mean? P less than 5, geometrically what it means is, so everything which is on this side, P1 less than 5 basically means this half space. So you can think of this as, this is where you have your x1 equals to 5. So when you say your x1 or the first coordinate, right? The first coordinate, if it's less than 5, what you're saying here is this whole half space, right? If x1 is greater than 5, it means this whole half space. So a simple if condition, like simple if condition like P1 less than 5 or P1 greater than 5, okay, is also like a line. This is also like a plane, right? If you think about it, just that this plane is parallel to your x2 axis, right? Now, but along with this, you're also saying that your P1 has to be greater than 2, right? Which means you're saying it has to be on this side of this line, and this is your line, which is x1 equals to 2, right? This line is nothing but x1 equals to 2. This line is nothing but x1 equals to 5. Now you are saying it has to be on the left side of this and in the right side of this, which means it has to be in this region, right? And what about this line? This line you can write it as x2 equals to 3, and this line you can write it as x2 equal to 4. Now since by having this first if P1 less than 5 and P1 greater than 2, you're limiting everything to this space. And now you're saying you also want to constrain the space on this axis. Now if you're saying that P2 has to be greater than 3, it's all this area, right? If P2 has to be less than 4, it is all this area. So by bounding it from all four sides, what you're getting is this region. So your if-else conditions can be thought of as creating, if you have four conditions like this, you can think of it, you can geometrically interpret this as creating an axis parallel rectangle, right? Now you can say whether a point is outside this axis parallel rectangle or not, right? Now this is what happens in 2D. Similar thing happens in